Well, that was exciting. Welcome to another exciting computer networks class. Sorry for the delay in getting things running. I had a little issue with my computer. Hopefully we're getting things back under control. I have already downloaded the Dropbox file, which people seem to have a little difficulty with. What I did was I saved it to a directory in my C drive, and then I proceeded to examine it using Notepad, and then I looked at it using Chrome. There are a couple of ways you can approach this problem, and I thought one of the things you might like to do, if you're just sort of interested in seeing what it looks like and looking at the code in a sort of objective way. I stored it in finance, by the way. Or at least I thought I did. dir star.main HTML. Enter. Nothing. Huh, how about that? cd dir star.html. Nothing. Well, let's see if we can't find it again. I'll go back to Chrome, bring up Blackboard.
Does this need to be saved in the directory with that project?
No. No, you can save it in any directory you like. Unfortunately, even though I had saved it, it doesn't seem to have acknowledged the fact that I saved it. And none of my courses are loading in Blackboard. Oh, here they are. So we're looking for CR320, course content, and finally I got to the file, copy, and what we'll do is we'll open up a new tab, paste, hit enter, and that should open up in your screen. Is this file giving people a hard time? Say it again, Rich.
To what? To read it? To save it?
Yeah, I mean, right now it seems to be taking a long time to open.
Yeah, you just have to like reload it a bunch of times, or else it will just say, "Oh, it's."
You have to reload it?
When I download it, when I open it in the browser,
Really?
none
I
of
just
the
saved
code.
it. I like saved it in the folder.
What do you click on here to reload it?
I mean, it loaded, right?
I'm sorry, I can't hear you, Rich.
You gotta click the X first, and then it should reload.
Okay, so that seemed to work. Now, for a download, there's an arrow here. Will that download it, do you think?
I just right-clicked the link and hit save as, and that worked fine. I had no problem with that.
We attached it in Blackboard also.
Yeah, we did.
So I can say download the current version. And did it download? I can't tell. Show downloads. Oh, here it is. Show in folder. There, I did download it. Now I should be able to cut it and put it into the C drive under Lion so I can find it. And paste. dir star.html. And there it is. Type main.html and pipe it into more. Okay. So one thing I can tell you for sure is it isn't an HTML document. However, it can be rendered as though it were an HTML document because many browsers are quite forgiving of improperly formatted HTML.
Why is it not HTML?
Well, it starts with the document tag and not the HTML tag. HTML
What if you
typically
save
would...
it to come up as a .html file, right?
Okay, there's a big difference between a file suffix and the file contents. The file contents in this case are what we care about. The file suffix you can change at will. If I change it to a .txt file, it doesn't make it a text file. It just will be treated as a text file. For example, if I said notepad main.html, Notepad will attempt to open it. The question of whether or not Notepad can do very well with it is another matter. And it seems to do okay. So that's sort of reasonable, right? If you look at this file again, let's say in Chrome, Control O will do an open, C:\lion main, there it is. So it seems as though Chrome is quite willing to render it to the screen. It seems as though Chrome is more than capable of taking a file like this and showing us its tables. And so therein lies what I think is sort of an interesting thing. Those tables contain a lot of data. And the data is formatted with some given headers, right? And so one of the things that might be really good is if you could manipulate this kind of data. And you'd say, well, if we're going to take the data off of the screen and convert it into our own internal data structures, then we are doing what's known as screen scraping. And screen scraping data is a favorite way to go out onto the web, which is our largest, fastest growing database on the planet, and convert it into data that we can then do processing on. So what I was thinking is maybe it would make sense for us to have a look at what XML is and how we could do a kind of XML processing with this data. Has anybody here ever done any XML processing before? I'm not hearing a yes. It sounds like this is something that's relatively new for you. So what I'll do is I'll give you my standard XML lecture, and what we're doing is we're covering chapter 32 of the book right now, which is sort of the introduction to XML and the simple API for XML processing, SAX, which is also called SAX. So the SAX API is a standard mechanism by which we can do our processing without having to actually build a parser. And sometimes I think it's very interesting when you have a language that enables a series of different things that you didn't have before. When you have that kind of language, it becomes a catalyst, and that catalyst can create a great deal of added value. For example, XML does to data what Java has done to programs. And what I mean by that is Java has made programs portable and has made programs so that they can be compiled once and run anywhere, provided you can compile them. Whereas XML is kind of a language that enables you to write new languages that will express a way to contain a wide variety of different data structures. So people have created a whole series of different XMLs or markup languages, and they've been using them and expanding upon them for a number of years now. So with an extensible markup language, that means you can write your own language. So I can have KML for Kyle markup language. and it'll be your very own language for expressing whatever you like. You could have HML for helicopter markup language, which might be very good for expressing all the different materials that you need in order to build helicopters. Right? You could have a special language for whatever you like. And you can use the same exact framework for parsing XML that you would use on any other language. So you get a reusable tool. And so this reusable tool enables you to avoid having to write your own parsers from scratch, and it gives you a nice, stable, and very fast mechanism that you can rely upon. And the key there is it's reliable. The hierarchy involved in XML is like a directed acyclic graph. That's a taxonomy. Is everybody familiar with the term taxonomy? Right? You guys are Java programmers, so what does that mean? When you use a class and you create a subclass, you have no multiple inheritance, so you have no cycles. An acyclic graph has no cycles. That means the leaves on the trees can't be connected to one another. That means that you can have an animal, and that a kind of an animal represents a subclassification or subclass. And one kind of an animal with a set that has a lower cardinality, for example, than the animal set, might be the mammal. Another kind of animal that has a lower cardinality than the animal set might be a fish. And then you could have a special kind of fish. A kind of hierarchy, or AKO hierarchy, is a taxonomy. One kind of fish might be a crab, right? The crabfish. The crabfish is an animal, for sure. It meets all the qualifications of an animal, but one thing we know is it's not a mammal. It's not that kind of animal. And one kind of mammal might be human, right? So mammals are certainly animals too, but while they inherit the properties from animals, they don't inherit all the properties from crabs, right? Because unless they're crab people, look out, it's the crab people, which you devised in your own little genetic lab. They'd be like a whole new species. Not sure exactly what the crab people do. They probably have craws, and they do something in the beach, like they crawl or something. So the crab people don't really exist. And so we have a directed acyclic graph. If you had crab people, you would have had multiple inheritance, because you would inherit the properties of the crabs, and you would inherit the properties of the people, which almost certainly means the people would taste good in butter or something, and the crabs would go to work every day. So I'm thinking that directed acyclic graph is what you get when you deal with a hierarchy in XML. It allows you to create something that's very similar to like an outline. So you can have, for example, an address book, which is a container of many addresses. Or you could have a catalog, which is a container of many products. And then one of the products might be records, and you could have a container of many records. And then you could put those all inside of your XML data structure. So here's a sample with a product called books, and then I can list all the books. And then there are properties within the books, and you could say, gee, look at this XML. It's looking an awful lot like a data structure, and it is. And a data structure, as I'm fond of saying, is just a stupid programming language. And so XML gives you a handy way to create a kind of stupid programming language, which lets you put in your arbitrary data. And then if you think to yourself, well, gee, this is working just swell for text, what happens if it's an image? Well, you have to convert the image to text, and that's the worst possible thing you could do with an image. Because if you have 1,000,000 pixels and you try and represent them as text, they're going to get very big. So it's really not good for binary blobs of any kind. But it's all right for text data. So then the question becomes, all right, how do I spec correct XML? And then the question becomes, what's correct? What does it mean to be correct? And so that's a very interesting question. Correctness, according to the XML parser, means grammatic correctness. It means behavior defined by grammatical rules, and then it means acting in accordance with those rules. And if you don't like the rules, that's your own fault because you can write your own rules. So you can't get too mad at the language for telling you you've made a syntax error because it's the error that's you've put in your own language. So there are a couple of ways in which you can define your own language in XML. The first way is called the data type definition file, or DTD. And that is the legacy method for defining a grammar inside of XML. The other way to define a grammar in XML is called the XML schema. You can do one or the other. In general, you will not see both, although it's possible to have both. DTDs still exist and are in common use today. XML schemas are the XML version of the data type definition language, and they allow you to use an XML-like format to define the grammar for the XML that follows. And so that's a very powerful way in which to define your own syntax. Now, the other thing you can say about correctness is it's completely optional. The parser is totally relaxed when you leave the data type definition or XML schema off. And it will go and parse whatever it is it encounters. And whether or not it happens to conform to any particular grammar, it won't know about if you don't give it the grammar. So we will not do any parse checking on the input data stream if you don't want it to. So typically, if you use the DTD, and this is the common one that I'll use, you start off with an angle bracket question mark XML. It's like, why? Why did they do that? Well, I don't know why, but that's what they've done. And it's become part of an ISO standard. So this is the International Standards Organization. And they've given you a standard code for it, 8859, and you make it standalone, and you give it a version number, and that's how you start and end your DTDs. And if you have a separate DTD with a doc type and some name of the item, then you could follow with a whole ton of elements. And I think the best way to deal with this is with an example. Here's a doc type called cart. So the cart could be like your shopping cart, and one of the elements in the cart is a product. And the product has to have a name, and it has to have a price, and then you might have some other product which is followed by just ASCII data called PC data. And so you can say, okay, product names could be something like records, where records is what they call # PC data. So records corresponds to ASCII data. That's a name, a terminal, a literal that appears in your data. And so you can say products all have ASCII names. So here's how it would end up looking once you start to encode it. So my cart has my book in it, and apparently it has some price associated with it. Now, suppose somebody puts in something like a price, and the price is silly. What would a silly price be? Something like just nonsense, right? They just type in bleh. You won't see XML necessarily complaining about it unless you've got a proper data type definition language. So if you haven't defined how it is that that price is to be formulated, the XML will just be good with it. It won't do any checking. And the only time you're going to have an error is at runtime when you go to parse the input. In other words, you might try and parse something like 45 euros, and maybe you're not able to handle euros, then you could just sort of bomb out and create a runtime error. So if you want to, you can build a reader that reads XML, and then you can use it for HTML, especially if you're willing to dispense with the DTD or the XML schema. And if you do that, then you'll be essentially building a kind of ad hoc HTML parser, a screen scraper. Also, you can write XML. And there are two things that I think are very interesting about XML when it comes to object-oriented languages like Java. They enable you to use XML for persistence. What's persistence? Rich, I can't see you back there. What's persistence? Yeah, you can store it. Persistent data means it can be saved. So what I can do is I can take an instance of a serializable object and I can run it through the standard XML encoder. XML will come out, and then I can take that XML and I can save it to a file. And then later I can read the XML or even edit it with some external XML editor and read it back in. And then get an instance of an object back. That's so cool. So the XML encoder needs some sort of an output stream to write to. I give it a file output stream, so it'll save to a file, but you could use any output stream. Then you write your instance of your serializable object out to the XML encoder, close the stream, which flushes the buffers, and then you've got a file and you've saved it. And you can go and edit it and look at it and behold the file, edit it, and do whatever. And then to read it back in, you have an XML decoder, right? So codecs require both coders and decoders. And it turns out all you need is a file input stream. Browse to the XML file you saved, and blammo, you can get back your object. So what do you need to do in order to make this work? You need to make your object serializable. That's key. And that's it. What else can you do to break things? When won't it work? Well, serialization is a very fragile thing. An instance of an object is like a cookie made from a cookie cutter. If you change the shape of the cookie cutter, let's say you cut the head off of the gingerbread man in your cookie cutter, then the gingerbread man won't be able to fit back into the cookie cutter because his head won't fit. So as a result, every instance that's being made from a class will only be able to be reconstituted if the class hasn't changed. If you add variables, if you change their type, if you add methods, if you change what they return, or if you change their arguments, you will break serialization. Serialization is a very fragile thing. So as a result, all of the data that you saved in the past depends upon a stable data structure that is being serialized. So if you're trying to serialize out your address book, you can change the address book around, but don't change the addresses. Because if you change the addresses, you will have broken the serialization, and no one will be able to read back all the data. If you want to, you can take an instance of an object and instead of serializing it out to a file, just serialize it to a string. In this case, I serialize it out to a byte array output stream, and then when I'm done with the byte array output stream, which looks just like an output stream, but instead takes the bytes and stores them into a big array, then I can take that big array and convert it to a string, and blammo, I've got an output stream that has become a string. I've written my object out all at once. Ostensibly, I have the memory for it. And now I can go and I can take that string and I can print it to the console, or I can mail it to a friend, or I can put it up on a web page. So I've got an opportunity here to be able to take that string and pretty much do whatever I like. There's a package available to you which contains all of my tools for doing these XML operations, and one of them is an XML toolkit called XML Utils, and it has all of these methods already built in. Static methods that you can invoke from anywhere. XML.utils.to XML, pass in an arbitrary serializable object, and blammo, XML comes out. That sounds like something we should try, right? Want to see? It's probably good to have a little demo. Let's just try a quick hello world in XML. just so that you can kind of get a feeling for it. So what I'll do is I'll go off to my little XML package. And I should be able to find XML utils. And there they are. And, oh, there's a main right there. Let's see what that looks like. Whoops. So let's see now. I got a bunch of ints over here, and I'm going to get the XML string off it, and then I'll print it. Then I'll decode the XML string, and then I'll take that and I'll make a bunch of ints, and then I'll print those. So I'll use the string for encoding this object, which will be an instance of an array. Then I'll take that string, I'll print out the XML, then I'll take the XML, convert it back to an object consisting of an array of ints, and then I'll print the array of ints. I'll get the array of ints back. So this is an example of encoding and decoding with an intermediate representation of XML printed as a string. How's that grab you? Let's see if that works. And there we go. So now you can see how the XML has been arrived at here. It says index 0 is valued 10, index 1 value 10, index 2 value 200, index 3 value 300. Takes the whole thing, and then I can reconstitute. Oh, index 3 is value 100. Sorry. So that seems to work reasonably well. You get an encoder and a decoder. What do you think of that? Good, right? What if instead of doing these ints, you decided you wanted to encode something else? Let's encode the date. Right. You encode the date as a string, then you print the string. That sounds fair. Then you decode the string. Now what is going to happen if you take the object and you try to cast it to something of type array of int? How's that going to work for you? The compiler doesn't seem to mind. Compiler's cool with this. Compiler's going to compile this. You're going to have runtime error. What kind of runtime error will you have, do you think? Hiroti, you awake over there? Yes? What kind of runtime error do you think you're going to have? Stack Overflow. I think it's going to be a class cast exception at runtime. We'll see. Yeah, there's a class cast exception at runtime over here. Why? Because a date is not the same thing as an array of int. And you can't just convert a date into an array of int by casting it. Not at runtime. And this date in here has been converted into a long. What do you suppose that long represents? Anyone? No guesses? It's a time in milliseconds since some date in the 70s, I think 1974. That's a little obscure, but that's what it is. So you can't do that, right? How would you fix this in order to make it work? No guesses even? Just cast it to something of type date. Because we know that's what we expect, and it'll come back as a proper date. So when you do decoding of XML, you'll get back an instance of an object where an object is just a descendant of the primordial java.lang.object class. But if you want to get something back that is of the same type as the thing that you encoded and that wasn't an object, then you have to know what it is to expect. Or you have to test the object and say, is this an instance of that? And if it is, then cast it. That's pretty poor code, but it's better to just know if you've serialized payroll, then what comes back is payroll. Suppose you wanted to take the instance of something and serialize it to preferences. Well, you could certainly do that, and you could take the byte array which contains the serialized instance and you could store it into the preferences directory. Now, preferences are interesting because they go with the user ID, which means if I log out of a computer in this room, but then have the same domain controller that enables me to log into a computer in my office, I should have the same preferences. And so what that means is I have a place to store data that's as secure as my login for Windows, which may or may not be secure at all, I don't know. So then you can now serialize things like passwords or credit card numbers, and you could store them all in your preferences with certain limits, size limits mostly. So if I've got a way to store bytes, I can store pretty much anything I like, including serializable objects. And if the objects are big, I can use compression. And if they're really big, well, I'll probably have to use a file system instead of just putting them out to preferences. And if I wanted to, I could stand to save not just bytes, but I could have nicely formatted XML, all stored into the preferences. And typically when you have an instance of the Windows preferences, all you really need to do is find a way to retrieve the preferences using something that's very similar to a file name, only they call it a key. And when you go to put something, you have a key and you use the key to put it, and then when you want to retrieve it, you use the key to retrieve it. So you have to know the key in order to be able to get the information back out. And you can supply default values in case it doesn't find what it is you're looking for. And there are user preferences, and then there are system preferences. And these are both part of the Java API from a very early stage, I think 1.3 or something like that. I'm willing to bet nobody here has used preferences before. Is that a fair bet? Yes. And what about this idea about keys and values? What kind of a data structure would you normally use to store keys with values? What would it be? A list. Well, a list just contains a series of elements. A collection is typically also a series of elements. But if you want those elements to map, that's the hint, to a specific key, how would you map it? Let's say I have, a number 13 and I want to map it to a value, and the value could be like some sentence. Suppose I said number 1 and I map it to the First Amendment. Number 2 and now I map it to the Second Amendment. Number 3 and then I map it. So now I've got a relation, right, between the number and the thing I'm trying to map to. So what kind of data structure would enable me to do that? Yeah, arrays would do it, but suppose that the number of numbers isn't sequential or particularly compact. Like I could have number 13 mapped to something and skip a bunch of numbers. So what would I use instead of an array? Yeah, a hash table, for example, would enable me to do that mapping. So you can use a hash table to model your preferences, but you'd still want to have it streamed to some place in the operating system so it would be available to you in a known area if you were to log out and then log back in. Let's see if we can do something about this. So we've got these wonderful tools now for doing reading of preferences and writing of preferences. Let's see if we can find them in here. There's a thing called the preferences utils, and it's in the utils package, and it's called preferences utils, and there it is.
You know about the search, right? In the top right, you can just like search it.
Yeah, but I kind of know where it is.
Oh.
I mean, yeah, you can do
I
that.
have no idea where it is.
You can certainly do that, but here it is. Here's the prototypical example. I've got a key called the test key, and now I'm going to go to my preferences, and I go to the user root preferences, and I can put hello world in as the key. Now I'm not just using a number like an array might use in order to index into a series of different containers. Instead, what I'm using is one string being used as an index for another string. So with these preferences, you have a general hash map. And if you wanted to, you should be able to do pr.get and then put in a key, same key, with the default value foo, end quote, end paren sem, and that should return an object. Let's see if we can get that. Yeah, it returns a string, string s equals, and now we can print out the string. And so let's see what happens when we put hello world in to the test key and then retrieve it. And it says hello world, which is exactly what you would expect. What do you think of that? So now I can take objects, I can store them into preferences. I can take objects and I could store them into,
What's
foo is the default value.
So what is that?
So if it doesn't find the key, let's say you use a key, let's assume I get a different key, and the key is and that key is not a valid key. So then the default value that it gets, since it couldn't find the key, will be foo,
Okay.
and then it should print foo instead of hello world, which is what you want, right? So now let's assume that you want to into the test key serialize an instance of an XML date, right? So now if I go to let's get our data into a string format. String data equals XML utils dot get XML string new date. Alt enter, Java util date, and now I've got a date in XML. And I'm going to take that date in XML and I'm going to print it just for a good time. Sout Control J enter data. So now I've printed my data, my XML data. Now I'll take the XML data and I will store it in the user root preferences using the key test key. Then what I'll do is I'll get the data using the same test key, and then I'll take the data, I'll print it, and the other thing I want to do is I want to decode it, XML utils dot decode XML string. And then I take my data, I put it back in. That should give me an instance of an object which is going to be of type date. Date decode cast it to type date equals, and he's giving me a hard time. What did I do wrong? I got the equal sign on the wrong side here. There we go. And then S out, Control J, Enter, and we'll print out the date. So now we've encoded the date as XML. Then what we'll do is decode the XML and print out the date. And that seems to work reasonably well. Yeah, sure. How's that grab you? So now I have an example of object serialization where XML is used as the intermediary for doing the storage or persistence, and I also have a mechanism by which that persistence is stored inside of the user preferences. As a result, anytime somebody logs in, they'll be able to go to their key and their preferences and use the preferences with the key in order to retrieve data structures. And those data structures can then be persisted based on login, which is a compelling and powerful argument. What do you think of that? Does everybody sort of understand this example? It's okay, right? You guys you're good with that? I'm getting the quizzical look from you, Kyle. It didn't work. Oh, it works good for me. Oh. Nobody else has this problem. Only you. Oh, that pisses people off when I do that. You know, I get that all the time from tech support. I never heard of anyone ever having that problem. I'll even make videos of me having that problem, and I think what they do in the office is they point and snicker and go, "Boy, look at that dummy." No, I don't. I'm sure your tech support is far more dignified. No, I was actually thinking about a brokerage firm that I was having to deal with this morning. You got it to work. Good for you. There you go. Good job. So, what I was thinking is, let me finish up this little PowerPoint deck and then we'll take a break. So we've got this nice example now. We can serialize. We're using XML. We're using preferences. I got several preference examples in there. Basically, you're taking one string, using it as a key, and then storing another string. And you could do the same thing with an array of byte. You can store strings with the key. You can store arrays of bytes with the key. You basically can store whatever you like, as long as you don't go over the limit. And there does seem to be a limit on how big something can be when you're storing things in preferences. So here's a good one. I like this. This is an example of a very complicated dialog box with lots of stuff that you have to figure out, and you only want to have to figure it out once. So what you really want to do is you want to take the data structure that's used to populate this dialog box and serialize it into the user's preferences. It can have things in it like passwords. It can have things in it like the locations of files and stuff that you might never change or rarely change, like the location of an image that's used to represent some sort of thing that you're interested in packaging. And so with this web start bean, which is what I've got here, I have a mechanism whereby I can serialize everything I need to deploy a Java application. And so I've got things like, and you can see it's all in here, the password, which is hidden from view, but actually available to the program internally. So when it opens up, it saves everything and gives you reasonable defaults. And you won't have to go and change everything every time. So having things serialized to preferences can make your code a lot more user-friendly. And the little dialog boxes that come pre-populated, that's so important in terms of making things come up with what I would call reasonable defaults. And that's my little presentation on serialization. What'd you think of that? Good, right? Everybody sort of understands.
I don't know if I'm seeing how we would use that too. So like mine new information.
So Kyle says, all right, so this is fine. We now know how to use XML if we want to encode serialized instances and decode serialized instances, and that's fine. But how is this going to help us with our data mining? And effectively, all we got was an introduction to XML. We didn't get the full-blown XML mechanism yet. And so I thought it would make sense for us to try and do something with what I would call the simple API for XML parsing. And so what I'll do after the break is, kind of getting a little bit ahead of me, is get into an area which we call SACS, where SACS is the simple API for XML parsing. And so let's take a break, and then we'll get and I'll try and address your question.